Homework 1.7, Inequalities, video 7. Homework due Saturday, May 16th, 2020 at 11:59 p.m. To wrap up this series of videos with either this video or possibly one more, we're going to take a look at absolute value inequalities. Now, I want to give you the same warning that I gave you in the previous video about polynomial inequalities. If in the homework you click View an Example or Help Me Solve This, it will show you a technique that is analogous to what I'm going to show you, but it's going to look completely different. So why am I showing you a different technique than the book? Easy. In the book, they show you a technique for solving linear inequalities, a different technique for polynomial inequalities, and a third technique for solving absolute value inequalities. But the technique I'm showing you will solve any inequality. So instead of going, oh, it's this the type of problem, so I have to do that now, you can just do the exact same thing we did before. The only real difference is how you solve. The way you solve an absolute value equation is different than how you solve a polynomial equation. But the protocol for everything else is still the same. So let's see if we can solve this absolute value inequality using this approach. The absolute value of x plus 1 is greater than 4. Sorry, folks. Okay. I'm not sure if I mentioned this anywhere in an announcement in Canvas or in any of the videos, but I'm not only your professor, but I'm the department chair, which means I'm over all math professors and I have to keep tabs on everything. So there were so many things that needed to be taken care of right now, being the second day of the Maymester term. So my apologies for the interruptions, but let us proceed. All right, so let's solve the absolute value of x plus 1 is greater than 4 using the universal approach, as I like to call it. So step number 1, change it to equal and solve. So we're going to solve the absolute value of x plus 1 is equal to 4. How do you solve this? Well, go back to the previous series of videos for homework 1.6, which I believe was module 4 or 5. I can check real quick. Which module was that? Module. It is module 5. So go back to module 5 and check out videos 7 and 8 if you need a refresher on how to solve absolute value inequalities. But in short, here's how you did it. To solve an absolute value equation, first you isolate the absolute value, this one already is, then you set up two equations. You set up the inside equal to the number, so x plus 1 equal to 4, and you set up the inside equal to the negative of that number, so x plus 1 equals negative 4. Remember, absolute value is distance from 0. This is saying that x plus 1 is 4 spaces away from 0, so it's either on the right side at positive 4 or on the left side at negative 4. And if we solve both of those, we get x equals 3, and we get x equals negative 5. But we're not out of the woods yet, because those values, and I wish this had been moved over and left me more space over there. I'm not going to stop the video and start over, I'll just make do with what we have. But those aren't our solutions, those are just the answers to step 1. Step 2 is to take these numbers and partition the number line. So we need to pick, well not yet, we need to take the number line and locate both 3 and negative 5. Negative 5 being the lesser of the two is to the left, 3 being the greater of the two is to the right. 3 is bothering me. And now I have to pick a test value from each interval. So I need a test value to the left of negative 5. Let's pick negative 6. I need a test value between negative 5 and 3. Guess what number I'm going to pick? 0. I will always pick 0 as a test value when the opportunity presents itself, but within a given problem, it can only present itself once. Let me silence this because I'm pretty sure I got that situation taken care of. Okay. And I need a test value to the right of 3. How about 4? So we need to test each of these in the original inequality. Luckily, the original inequality is pretty tame and won't take much room. So let's try negative 6 in the inequality. Absolute value of negative 6 plus 1 is greater than 4. Or is it? That's what we're checking. Absolute value turns things positive, but they're also like parentheses in the sense that you have to do the inside first. So if you're looking at this and thinking it's 7, then you turn the 6 positive and then add it, but it's not time to turn it positive yet, because I don't know what number's inside of here yet until I do the addition. Negative 6 plus 1 is negative 5. The absolute value of negative 5 is 5. So is 5 greater than 4? Yes, that is true. I like that interval. It will be part of my solution. Let me shift colors. And that's just for readability, unless you're colorblind, in which case, my apologies for shifting colors because it didn't matter. So let's test x equals 0 in the original inequality. Absolute value of 0 plus 1 is greater than 4 is what we're asking. Well, 0 plus 1 is 1, so with the absolute value of 1 is greater than 4, but the absolute value of 1 is 1, and the statement 1 is greater than 4 is false. So we do not want the interval that the 0 came from. And then lastly, for x equals 4, and by the way, you can check these verbally or mentally. You don't have to write it all down. I'm doing that for instructional purposes. If I were doing this just on the homework, I would grab this 4 and think 4 plus 1 is 5, absolute value of 5 is 5, which is greater than 4. It's true. But for instructional purposes, I'll write it down. Take the 4, put it in for the x. Absolute value of 4 plus 1 is greater than 4 is what we're asking, but 4 plus 1 is 5, and the absolute value of 5 is 5. 5 is greater than 4, that's true. We like that last interval. So now for our answer, we're going to keep the intervals. There are 2 of them, so we will need a union, but we'll use brackets or parentheses. Parentheses. Because it says greater than, not greater than or equal to. All right, the left interval starts at negative infinity, goes all the way to negative 5, not negative 6. Negative 6 was the test value. The partition value that cut the number line into intervals was negative 5. Both with parentheses, infinities because they always get parentheses, and then negative 5 because it said greater than, not greater than or equal to. And we are going to have to union this with another interval. The other interval was the one to the right of 3. And so that was from 3 to infinity, both with parentheses. So as you can see, solving an absolute value inequality is just like solving a polynomial inequality, with the exception of how you solve the first move. But the rest of it, the partitions, the test values, the passing of judgment on whether an interval makes the inequality true or false, are all the same. We are going to do one more video because I want to show you a problem where something unanticipated happens, but it doesn't really make the problem any more difficult. I would argue it makes it easier.